Hello everyone, this is Sanjana Kushwaha from third year EC department, and today I am going to discuss a problem on how to plot the magnitude and phase response of FIR filter using Bartlett window. So first let's try to understand what does windowing means. A window is a finite length sequence. Windowing is a process of forming a finite length sequence from an infinite length sequence by multiplying an infinite sequence with a window. It is equivalent of multiplying the signal sample by a window function of same length. The choice of window is to have W of n as short as possible in the duration so as to maximize the computation in the implementation of the filter while having capital W of e to the power j omega approximate an impulse. A window must be applied to the data to minimize the signal leakage effects. There are various types of window functions. Some of some used in the vibration signal processing are rectangular, Bartlett, Hamming, Bachmann, Kaiser, and etc. But for this video, we will be focusing on the Bartlett window. So let's see what is a Bartlett window. Bartlett window is a very similar to a triangular window, except that the endpoints are at zero. It is often used in signal processing for tapering a signal without generating too much ripple in the frequency domain. The transition width of the main lobe in the case of Bartlett window is equal to 8 pi by m, where m is the length of the window. It has tapered sequences from the middle on the either sides. It is given as Wt of n equals to 1 minus 2 mod of small n by capital N minus 1 for the values of small n ranging from minus n minus 1 by 2 to capital N minus 1 by 2 and 0 for other values of n. It is also given as Wt of n equals to 1 minus 2 mod of n minus capital N minus 1 by 2 by n minus 1 for values of small n ranging from 0 to capital N minus 1 and 0 for other values of n. The frequency response spectrum of a triangular window is obtained by taking a Fourier transform. Here is a Matlab simulation of magnitude response of a Bartlett window of length equals to 64. We can see that from the frequency plot that the transition width of main lobe is equal to 8 pi by m, whereas it's 4 pi by m in the case of rectangular window. Unlike rectangular window, the Bartlett window has a smoother transition from 0 to 1 and vice versa. We can also see that the peak approximation error is around minus 27 dB in case of Bartlett window, whereas it is around minus 21 dB in case of rectangular window. So we can say that the convolution of two rectangular window is a triangular window and the main lobe is twice as wide as that of triangular window. The first side lobe is twice as far down as the rectangular window, and this is also known as a tent function. Now since we have understood the basics of Bartlett window, let's look into the general procedure for windowing. Let's see the steps for windowing. First step is to choose a desired frequency response of the filter, capital H d of omega. Next step is to take the inverse Fourier transform of capital H d of omega to obtain the desired impulse response, small h d of n. Now choose the window sequence W of n and multiply h d of n by capital H d of n to convert the IIR to the FIR, which is given as h of n equals to W of n into h d of n. Now we'll be taking the Z transform of h of n so that we can obtain the transfer function capital H of z. Last step is to realize a filter using suitable filter method. Let's see the steps in more detail. The first step is to find out the capital H of omega and the cutoff frequency omega of C. The equation can be given directly as h of omega equal to e to the power minus j alpha omega, where alpha can be calculated as capital M minus 1 by 2, where M is given as the length of the samples. The phase delay is given as by the value of alpha, which can be calculated from capital H of omega. The cutoff frequency f of c can be given and can be find out with the help of omega of c, which is given by 2 pi into fc. The sampling frequency f of s can be given, and with which you have to find omega is equal to 2 pi fc by fs. The next step is to find out the value of h of n of the IIR filter response by taking the inverse discrete Fourier transform of h of omega, which is given by small h of n equals to 1 by 2 pi integral ranging from minus pi to plus pi capital H of omega into e to the power j omega n d omega. The next step is to find out the function to get the coefficients pertaining to the window function. You can form a table similar to the one given below for better understanding. You have to identify the windowing function based on what window you are using, as you can see from the table. Substitute the value of n into the table and find out the desired frequency response x small h d of n. The next step is to find out the final equation after window technique has been applied. To identify which of the values from the table should be included, we need to solve this equation and substitute the respective values from the table above. After simplifying and solving this equation, we will be getting the final transfer function. And the last step is to transform this final equation using depth transform into the z domain. Since we have understood the basics, now let's dive into the problem. The problem is determine and plot the magnitude and phase response of the filter using a Bartlett window. So the first step is to find out the value of capital H d of omega, which is given as e to the power minus j alpha omega. Here we can see that capital M is given as 25. Therefore, the value of alpha can be calculated as m minus 1 by 2, which is equal to 12. That is, to obtain the desired length of 25, a delay of 12 is incorporated into capital H d of omega. Hence, the value of H d of omega is equal to 1 into e to the power minus j 12 omega for omega ranging from 0 to pi by 6, and it is 0 otherwise. The next step is to find out the value of h of n of the IIR filter response by taking the inverse discrete Fourier transform of capital H d of omega. Small h d of omega can be given as 1 by 2 pi integral minus pi by 6 to plus pi by 6 capital H d of omega into e to the power minus j of omega n d omega. After calculating, we will find out the value of small h d of n as sine pi by 6 into n minus 12 divided by n into pi into n minus 12. The next step is to find out the windowing function to identify the windowing function, and here we are using the Bartlett window. So substitute the values of n into the function to get the coefficients pertaining to the window function. Here Wn is the Bartlett window of length n equals to 25 and is given as 1 minus 2 into n minus 12 by 24 for small n ranging from 0 to 24. Hence we will be finding h of n equals to small hd of n into w of n, and we will be substituting different values of n and finding uh, various values of h of n. The next step is to find the final equation after windowing technique has been applied. To identify which of the following values are needed from the table should be included, we need to solve this equation and substitute the respective values from the table above. Here we are supposed to find out the magnitude and phase plot of this filter, so we will not be solving this problem manually, but we will be solving this equation using Matlab, and we'll find out the magnitude and phase plot of this filter. So here is a Matlab code. And here we are using the Bartlett window function, which is available in the Matlab library, and we are using this to solve to find out the magnitude response and the phase response of the FIR filter uh, given in the question. So from this code we can see that we'll be getting the magnitude response of the magnitude response and the phase response like this. Here we have frequency in the x-axis and magnitude in dB in the y-axis for the Bartlett window. And here is the phase response, angles and frequency in the x-axis. One thing we need to note here is that the magnitude responses using Bartlett window are poor because the transition region is very wide. To obtain a sharper cutoff, we must increase the length of the filter. Hence, to obtain a sharper cutoff, we need to increase the length of the filter, and this is how we can find out the magnitude and phase response of a FIR filter using Bartlett window. Thank you.